name is Harshal and this is operating system lab experiment number 8, page replacement algorithm. So in this experiment we will see what is a page replacement algorithm for the FIFO, LRU and optimal. So let's begin the video. In the description as we see what is a page replacement. So what is a page replacement? When we need a page but that is not available, so that we can replace it. So that is known as a re- page replacement. So page replacement is a base to demand paging. So what is a demand paging? Demand paging is if that page is not available in the memory and we want that page, so that condition is known as a demand paging, and we will fetch from the from between the logical and physical memory. So that mechanism is known as the demand paging. And there are the three types of page replacement, that is FIFO, that is first in first out, LRU, and optimal page replacement. So that we will see in the further when we do the programs, and we will see the result of the FIFO, LRU and optimal. So what is a FIFO? FIFO is a page replacement algorithm, so that when the page is available, means the first when the first page is inserted into that, and when we need the another page, so that and that will be in further, so we will remove that page, and we will insert. So first come first of like that, first in first out, so like that it can work. And next we will see the LRU, that is least recently used, means the earlier we were using, so it will go into the past and see the what is the page, and then it will replace. So that is known as least recently used. And optimal page, that it will see the that is the best algorithm in the replacement, that is the optimal. So that is, it will see the further references, and then it will replace the page one by one. So we will see each every term for the FIFO, LRU and optimal. So what is a page fault? A page fault happens when a running process access a page memory page that is mapped into the virtual address space, but it is not loaded into physical memory. So page fault occurs when we try to access the page, but that is not actually, or that is physically, that is not loaded into the page. So that is known as the page fault. So page fault means when you try to access some part of the page, but you are not able to access, so that is known as a page fault. So what is a page hit? If we want to if we find the required page in the main memory while CPU wants to access the page, so that is known as a page it. Means what it's mean, we are trying to access the page, and it is required, it is already existing, so that is known as a page it. So that is already that is required, and that is loaded already, means we want one page, but the page is already existing in the memory, so that is known as a page hit. So we will see the algorithm, that is first we will find the location of the desired page in the disk. Means on the disk we will find the page, then there are the frames such as 2 3 4. For that replacement we will need a frame. So first what will it come? First it is null, means it is empty, nothing is there inside. So first the page fault will occur for each and every page that is available, that we are going to load in the memory. So that is that the page fault will occur. Then next, when we are going to see in first in first out, LRU, least recently used and optimal, then we will get to see how this algorithm is used, and we will get the output according to that. So here what it will do, that find the frame. If the frame is free, then it will insert one by one. If it is If the frame is full, then the page replacement algorithm will occur, such as FIFO, Alarion optimal, so that it can do the page replacement, and then it will read, and then the pages will be free, so that we can see the total number of misses, total number of page hit, and we will see the total number of page fall, so that we will see, and how the algorithm works we will see in the further. So this is the first out. So this is the simplest page algorithm. So here, this is the page algorithm. It will execute one by one, so we will see how it's work. So this is the page algorithm. So we have frames of 3, so this is the 3 number of frames, and we have 7 number of page reference, that is 1 3 0 3 5 6 3. So this is the page references. So first everything is empty, so this is the frame of 3. So we will see how the page fault are found. So here we will see, first everything is null, then we will enter one. So first page occurred is there, then second page will occur, page fault will occur, and third. So this is the page fault for 3. So first, earlier this page is loaded, so next we will see the third one. So is third one we are going to need. So this is this is already existing, so this is known as page hit. So we want to access the memory, but page, but it is already loaded into the memory, so that is known as page hit. So at 3 the page is hitted. So next we will see the uh, which it is not needed. So one we are not going to need, so we will pop out one and enter 5. So 5 sorry 4 page fault are occurred here. So next we will see it is available or not. So 0 3 and 5 are inserted into this. So next we will see, we will move to 6. If we are going to load 6 here, so we will pull out 3. So 3 is popped out and 6 is entered here. So this condition we will pop and enter 6. So this what is happening here, we are next the page is coming 3, but we already popped out. So that is page fault occurred. But this is the problem in FIFO, that we want the page in further, but we popped out earlier. We will need that. So this page problem are occur. So the FIFO is getting problem. So here, next we will remove remove 0 and insert 3. So the total number of page faults are occurred here 6. So because of that, the page fault is occurred, the total number of page fault is occurred, that is 6. So we will move to next. So this is the optimal page replacement. So what is optimal page replacement? So this is the best algorithm for the page replacement. So we will see what it will do. So it will check, this algorithm will check the further references, and according to that it will pop out and push in the pages. So we will see. So the page references are 13 here, and number of page frames are 4. So for 7012 4 page faults are occurred here. So next it will go to the further, and we will insert 0, but the 0 is already here, so we will don't need 0. So the page it will be occurred here. Next we will see 3. So we are going to need 3, but in future we are not going to need 7, so we will pop out 7 and enter here 3. So 3 is entered here. So after that we will need 0, but the 0 is already here, so we will hit this. Next we will move to the 4. So 4 we are needed. So earlier there are 4 hits. Next 1 is occurred, so this is already here. So we will enter here 4, and we will enter here 4, So this will go outside. So 4 is there. Next it will go to check 2, but the 2 is already here. So this will be page 8. Next we will see 3. So 3 is already available. This will be 3. 0. There is already there. Next 3, 2 will be also available. 3 will be also available. So in future we are not going to need 7, so we will pop out 7 and 1. So we popped out this 2, and the total number of page faults we got, that is number 6. So this is the optimal page replacement. Then we will go to the next algorithm, that is known as least recently used. So this algorithm works in least recently used. It will go forward and check the last used pages. So the same number of 30 number of page reference are there, and frame is 4. So 4 page fault are already occurred. So next we will go to 0. So we will check in the last whether we are going to need 0 or not. So 0 is already there, it is already loaded, so we will not going to need. Next we will go to 3. So here we will check if we are going to need 3. So 3, so we will go to the last. So this is recently used, 2 is recently, 1 is recently, 0 is recently, but we are earlier of that. So we will see last, that is not going to use in uh, not recently used. So 7 is not recently used, we will pop out 7, and then we will enter 3. So next we will go to 0. So 0 is already used recently, so we will not push 0. Next we will move to 4. So here we will check if we are going to need 4. So if it is not there, then we will pop out, we will check. So this 0 is recently used, 3 is recently used, 2 is recently used, and 1 is recent. It is this one is previously means a long time ago we used this. So 1, then we will pop out 1 and enter here 4. So 4 came here. Next we will go to 2. So we the 2 is already existing in the frame, so we will got a page 8. Next 3, so 3 is also available, so we will get a page 8. 0, so we will check 0. So 0 is also available, so we will get page 8. 3, 3 is recently used, so we cannot pop out 2. So 2 is already existing, we will not pop out 3. So 3 is recently used, so 3. So we got total number of page fault, that is number 6. So this is the last recently used. This is the optimal page, and this is the FIFO. So now we will go to the programs and see what is the program for FIFO. So this is the program. So here is the constant, that is the memory size that is given here. This is for the number, frame size, page and mark. So here in the queue it will wait. So total number of page fault, it will be 0 because nothing will be there. Next for inserting we will go there and check if the it will go one by one, and it will check the page. So if it is marking the page mark is of im is equal to true, means if this number is already existing in the page, so this page, so this will occur, page is not causing a page fault, means that is already occurring inside, so that is a page 8. So this line will show that the memory page is already that is existed into the memory, so this will not cause a page fault. Next, if it is occurring, so what it will do. So in queue it will push the page inside, and it will check if the mark of page is equal to true. So this will check true if the queue size, means the size of inserted, that is greater than frame size, then it will insert into the front, means if we have 3, it will enter into the front one, and it will mark the present one, it will false, and then it will pop out, means here if it is there, if it is there available, so this will pop out there, and if that is this is pop out, then it will increment by 1, means this will increment by 1, and then it will show that the page fault is occurred here, and then it will print the total number of page fault. So here it will ask, enter the number of frames, enter the process length, means how many processes, and enter the process. So here this function will call, then we will get the page replacement of p4. So let's run this program. So here we got the page frames. So here we will enter frames 3. Next we will enter the process. So let's check how many process. 1, 2, 3, 4, 5, 6, 7. Okay, so 7 processes. This will ask enter. So we will enter 130, 130, 3, 5, 3, 5, 6, and 3. So this is the total number of page faults that are occurred here at 6. So let's check. The page fault is occurred here because everything was null. So here 130, 3 page faults occur here. Next for 3, so 3 was already available. So here it does not cause a page fault. So 5 was not available. So we popped out 0 and inserted 5, then 3 by 6, and 3 was 6 was already available, so total number of page faults we got here 6. So moving to the next, we will see the, so this is the optimal page replacement algorithm. So this is the constant, so this is the memory size as above. So here in the vector it will ask the frame rate, then it will see the further references. So here in for loop it will if I is less than n, so here it will go into the k. So this is the frame size, it will increment, and if the frame size it is equal to the page size, then it will break. And next it will uh, it will break and come outside, and it will show the total number of page faults. So this condition is used here, and if the k means this k is equal to frame size, then it will go means fr size. Fr size is less than frame size, so it will push back the page, means it will push back the page, and it will enter in, it will push the page backward, and it will enter. If this is not there in index, it will increment by 1 by 1. This is the, this is the rest, means the future one, it will be minus 1, mean the it is already existing, it will go back, and the farthest it will be index here, means this will further one, it will be to the index. For l is equal to 0, l is less than f dot frame plus plus, then j, if j is equal to index and j is less than j plus plus, then it will go inside and check the condition. That is, if it is there, it will go inside, and it will go further, and it will check if the page is already there, and it will go inside, and it will assign the number for the furthest and the previous one, and then it will break condition, and it will show that the if the page fault is occurred or not. So here if it is occurred or not, so here it will check. And then if j is equal to number, means it is equal to number, means this when we enter j and the number is equal, so it will page it, so it will break, and it will go outside, and in the further reference page it will go increment. So if this is true, then it will show the page fault is occurred or not. If it is occurred, so it will show here occurred, or else it will go back and it will show the page fault does not cause. So here in the main, it will enter the frames. We will enter the frame process and process line, and this will we will check the output of this program now. So here we will enter the frame here for the number is 13. So we will enter here 7 0 1 2 0 4 2 3 0 3 2 3. So for this first four, we will get the page fault occur. Next, it will go to 0. It will check the 0 is already existing, so does not page fault occurred. 3, so 3 was not available. So for 3, the page fault occurred. 0 0 is already existing. Page fault does not occur. For the 4, 4 was not existing, so here page fault occur. So here 3, 3 is already existing. So it is for the 2, 2 is already existing, so page is not awkward. For the 3, 3 is already existing, so this is not awkward here. 3 is already existing, then 0 is already existing. 3 2 3, so this is already available. So total number of page fault we got here 6. So this is the LRU. So list recently used. So this is the program here. So we will check how it's work. So this is the constant memory, this is the frame size, and in order here, unordered set, we will take input of s, and unordered map for integer, we will get indexes. So here we will go inside the for loop. So it will find if the recent list one, if it is equal to, it is not is equal to end, means list one, that is if it is equal to, then it will go in else part, and if it is not equal to, then it will show the, means if list we used that, means recently we used that. So for that, page is not page fault is not occurred, and if it is occurred, so in else condition we will check. In else condition, if the s size means this s size, that is great, that is less than frame size, so it will enter the page, and it will increment one by one. So increment one by one. Next, it will go in else part. Int LRU list recently used. For int max, it will go auto. This is the function auto. Then it will assign the value, and it will go inside if loop. If indexes item is this auto function it, it is less than LRU. So LRU will be assigned to the index, and value that will be assigned to this. So this it will check here list recently used. So it will check here this value will be equal. So here it will check if this is recently used, so it will be removed, and then this will be replaced. So here it will insert the page increment one by one. So here when it is entered here, so here it will show the page fault is caused here. Next, it will if it will go and check the indexes page, and I page it is equal, then it will show the number of page faults here. Here it will ask the number of frames. So frames, number of process length, and process. So here when we check the output here, so frames are 4, input are 30 numbers. We will enter 7 0 1 2 0 3 0 4 2 3 0 3 2 3. So here it will check the total number of pages are 13. So here 7 is there. So first for it will cause the page fault. Next for the 0 it will go last and see recently. So 0 is recently used. So for 0 the page fault is not occurred. So 3. So at the last 7 is at the last it is long time used 7. So for the 7 it will cause a page fault. Then for 0 that is recently used page fault did not occur. For the 4, so here it is not occurred. So for it will replace by 1. And for the page fault is occurred here. So for 2 is recently used, so it will does not cause. 3 it is recently, 0 is recently, 3 to 3. So the page fault are occurred, that is number 6. So like that this algorithm works. So this was experiment number 8, page replacement algorithms of operating system lab. Thanks for watching my video.